Hi everyone, this is example 5 on orifices, tubes, and weirs under steady flow. The liquid in the figure shown has a specific gravity of 1.5. The gas pressure P sub A is 34.50 kilopascals and pressure at B is negative 13.8 kilopascals. The orifice is 100 mm in diameter with coefficient of discharge equal to coefficient of velocity of 0.95. So determine the velocity in the jet and the discharge when h is 1.2 meters. Then next, neglecting vapor pressure, what is the maximum percentage by which the discharge can be increased by decreasing P sub B? So here is the situation. And for the first question, velocity in the jet is c sub v square root of 2gh, where h is upstream head minus downstream head, and the upstream head is 34.5 pressure head over specific weight of liquid plus 1.2 h. Then the downstream head consists only of the pressure head at B, which is minus quantity negative 13.8 over specific weight of the liquid 1.5 times 9.1. So h is 4.482 meters. Substitute into the formula, so V is 0.95 square root of 19.62 times 4.482. So the velocity in the jet is 8.909 meters per second. Then the discharge is kaotog, or area O times actual coefficient of contraction area O times square root of 2gh. But since C is given equal to 0.95 also, so we'll use this Kautog formula. So Q is 0.95 times pi 0.05 radius meter square, then square root of 19.62 times H, which is 4.482. So discharge is 0.06997 cubic meters per second. Then for 5.3, since vapor pressure is neglected, if the vapor pressure is known and not neglected, then we should reduce the pressure at B to its vapor pressure, because at that value be lower than that, it will produce cavity in the right portion. So in this case, since vapor pressure is negligible, then we can reduce pressure at B to absolute zero, or negative 101.3 kilopascals gauge. So the pressure at B should be negative 101.3 kilopascals gauge, so that the discharge will increase. So there is suction in this, perfect suction vacuum in this chamber, so that the new H would be 34.5 over 1.5 times 9.81 plus 1.2 minus quantity negative 101.3 over 1.5 times 9.81 pressure head at B. So H this time is 10.43 meters. Substitute into the formula for Q. Q is 0.95 Q prime pi 0.05 square times square root of 19.62 times 10.43. So the new discharge is 0.1067 cubic meter per second. So the maximum percentage increase in the discharge is Q prime minus Q all over Q times 100%, or 100% times quantity 0.1067 minus 0.06997 over 0.06997. So maximum percent increase in discharge is 52.49%. So that's it for this problem.